In-Memory Database by Rachel Vibert. The topics of my presentation today are what is in-memory database. I'll talk about some of the differences between disk storage mechanism versus main memory mechanism. I'll talk about the ACID model databases, the in-memory operations, and some advantages and disadvantages of in-memory database, and finally some examples. What is in-memory database? An in-memory database is a database management system that primarily relies on main memory for computer data storage. In-memory databases put the working set of data into system memory either completely or partially. And it is not just storing the data in memory, but it is also performing operations in memory, which I will talk a little bit about later in my presentation. So now I'm going to talk about the disk storage mechanism, which is kind of the traditional way of storing data. So in the disk storage mechanism, all data is stored on the disk. And then in order for the information to be received, and disk input output is needed to move the data into main memory when needed. So whenever you are trying to access your data with a disk storage mechanism, the data has to be called upon and then transferred from the disk storage to the main memory in order for the user to see it. Also, the data is always persisted to the disk, which means that it's on the disk. It has to be on the disk, stay on the disk. And then the data must be transferred to numerous locations. So in the picture that I have here, it kind of shows all of the different locations that the data needs to go to with the disk storage mechanism. So it has to go from the application to the database runtime, to the DB cache, to the file system, to the FS cache, to the file medium. So it just has to go through a lot of different things in order for the data to be received, which can take a while. Versus main memory database, which is in-memory database. And with that, all data is stored in main memory. So there's no need to perform the disk input output to query or update data. The data is persistent or volatile depending on the in-memory database product. And there are specialized data structures and index structures that assume data is always in main memory. So this means that when you need the data, the specialized data and index structures know that the data is in the main memory rather than on a disk like before. And the data is stored in something called random access memory, or RAM. And in my picture here, it kind of shows how many less steps that it takes in order to get the data from main memory versus how many steps there were for the disk memory. Only 3 here. So the ACID model of database characteristics means that it's basically just a mnemonic device used for the characteristics that a database should have. And the ACID stands for automaticity, consistency, isolation, and durability. And like on my picture I have on the side here, atomicity stands for, or means transactions are all or nothing. Consistency means that only valid data is saved. Isolation means that transactions do not affect each other, and durability means written data will not be lost. So in-memory databases only conform to 3 out of 4 of these, and the one they do not conform to is durability. And this is because the in-memory databases are volatile, and that means that when the power is lost, data can and will be lost. So durability means written data will not be lost, but the durability model cannot be served because, in fact, data will be lost when the power goes out when it comes to in-memory databases. So some in-memory operations, this kind of means that not only does the in-memory database store your data, but they also, can perform some operations that make it more helpful. So one of them is this FTB, and an FTB is an in-memory structure that can be used with unique indexes. And so a DB2 detects which indexes are frequently used for traversals, and when a threshold is hit, DB2 will build an FTB for the index in a storage area outside the buffer pool. This causes the top levels of the index to be cached, thereby making it efficient to perform very fast traversals through the cache levels of the index. So basically what an FTB is like, it's a structure that helps people to receive their data quicker, because the FTB kind of like tags well-used data or indexes, and it will kind of like create an FTB around and kind of almost like save it so that I can go more quickly to the user. Also, the in-memory operation could be that data is kind of stored in a more organized way. So like one of those, and one example of that would be that it couldn't be organized into a column and rows. So like sometimes with traditional data, it was only stored in columns. So in that case, some data was more repetitive because it was in there more because there was only one column. But with in-memory operations, it can be stored in columns and rows, which helps with redundancy a lot. And then an example of this is the SAP HANA, and it enables real-time analytics on a large scale and on a variety of data. It combines database, data processing, and application server capabilities, all running in memory on one data set and on a single platform. So that's just an example, because it's not just storage, they also have some operations that they do as well. So what are some advantages of in-memory databases? I would say that the first advantage would be the speed. And when a user queries a large data set, it takes time to process information requests when data are stored in traditional hard drives on disks. It takes only a fraction of this time to search in-memory data, because RAM eliminates many of the issues that cause traditional databases to operate at a much slower pace. And then some of these issues that the in-memory database doesn't face is some design issues and some synchronization. Also, real-time decision-making is an advantage, and this means that in-memory data helps ensure that decision makers have the most relevant and timely information available when they're speaking to a customer or even management of their own company. This information helps them to present an accurate picture of where they are now in the company. Because the memory is so much easier to quickly load and upload. This means that decisions can be made at real time. They don't have to wait for the data to upload. They can they see it right away. So it's just easier to make real-time decisions. It reduces the burden on IT resources, and this means there's a low cost of memory. Databases themselves have to be designed efficiently, which means less redundancy in data tables, like I was saying earlier. Furthermore, so the data is compressed to help them fit into smaller confines of memory as opposed to storage. So as a result of that, there's less need to purchase servers equipped with large hard disk drives, and resources are saved. So with the in-memory databases, there's more, they can compress the data so that there's more space for more data. And then finally, big data management. In-memory database helps in big data management because it is used with applications that allow very fast data access. So the storage and manipulation, even in systems that don't have a disk, but have the need to manage large volumes of data. So large volumes of data can be processed through in-memory data, and they can be accessed a lot faster than through a disk. And then some disadvantages of in-memory database. The first would be cost. So it is less expensive to have memory in a disk than it is for in-memory database. It's just less expensive, or it's just less expensive for the disk. But the cost of in-memory database, the cost of in-memory is going down. Another disadvantage would be adopting a new database system. Companies would have to get all new tech people. They would have to get all new systems. It would take, a little bit of transferring over. So that would be a disadvantage of, having to adopt a new database system when maybe a company doesn't necessarily see a problem with their current database system. And then, some of the changes that people are making with information technology, with in-memory databases is causing the speed to be affected. So, some of these operations that people are adding on could affect how quickly the data is able to be accessed. And then finally, some examples. Kind of some of the big, most famous examples of in-memory databases would be the SAP HANA, which I talked about earlier with regards to the data processing run with the database and application server capabilities all running on in-memory. And then another famous example is the Oracle x10 and the VoltDB. So in my article today, I talked about what is in-memory database. I talked about some of the differences between disk memory and in-memory. I talked about what the ACID scale was. I talked about some of the advantages and disadvantages of in-memory database, and I talked about some examples. These are my sources, and thank you for watching my video.